Hello, I'm Jim Van Buren with the Manitoba Geological Survey. Today I am situated on the world's biggest sandbox. As you can see in front of me, there is sand, and it tends to behave like a solid rock until you hit your hammer into it, and then it totally crumbles. This sand is very, very old sand. It is close to 550 million years old. It is about the oldest sand we have in Manitoba. The sand is extremely rich in terms of silica. If we look at the chemical composition, it comes in about 96% silicon dioxide. So it is an extremely silica-rich sand. And it is directly above the Precambrian rock in Manitoba. And the Precambrian rock ranges in age from about 2 to 4 billion years in age. When the Precambrian was done and finished in terms of being a geologically active unit, at least in Manitoba, at least geologically active in terms of eruptions and metamorphism and so on, it was then covered by a very, very rich silica, or silica-rich quartz sand. And this sand is very what we call mature. If you look at individual quartz grains in the sand itself, which you can't possibly see at this distance, so you'd need a microscope to see it, but the sand is well-rounded. Each little quartz grain is like a tiny little ping pong ball kind of shape. It is extremely round, and the sand size ranges can be almost to a silt, which is extremely fine material, and it gets coarser until it's almost like you would find in a sandbox, typically much coarser sand. This is the same kind of sand that you find at Grand Beach on Lake Winnipeg, where the sand there is maybe about 70% of this Ordovician sand, this 550 million year old sand. And we are at the bottom of what we would call the stratigraphic column for geology. We have an interval of rock above the Precambrian called the Phanerozoic. And the Phanerozoic can be divided into three groups. We have the Paleozoic rocks at the bottom, the Mesozoic rocks in the middle, and the Cenozoic rocks at the very top. Well, we're at the very bottom of the stratigraphic column in through here. So where I'm sitting right now, there might have been up to a mile of thickness of sedimentary rock above my head. This has all disappeared through geological time, and we're sitting on the present surface here. And behind us is maybe a bit of a reason for how this sand was preserved when all the other sand surrounding us, if you move roughly a mile in any direction from this particular outcrop, there is no more silica sand here. You have to travel all the way across a strait of water to an island called Black Island, which is across that strait. And at Black Island, this same sand is present there, and it was quarried there by a company called Marine Transport. And Marine Transport, through a subsidiary called Silcrete Silica, used to supply the same kind of sand, the same very fine quartz-rich sand, for a variety of purposes. Some of it was used in the glass container factory business, where the bottles that you might have purchased back 40, 50 years ago would have come out of Alberta, and they had a plant there that used to make glass bottles. Some of it would have also gone into the frac sand industry, where it was used to fracture or to preserve the fractures in rock to allow greater oil and now natural gas production to come out of the rock deep within the earth, maybe a mile or two down. So that's where some of the sand might have been utilized. Some of it actually was used in concrete, for a very white concrete. And I can remember my parents' driveway on Semple Avenue in Winnipeg. They had a very white driveway. Other neighbors would look at and say, well, how did you get such white cement for your concrete? And it was the silica sand that was added to that mix of concrete that made it very white. So anyways, this is part of this remnant. Like I said, a very, very old sand, the oldest sandbox in Manitoba. And again, very deceptive. It looks like this sand is going to be solid. You can't break a piece of it. It just shatters into a million pieces. You pick it up and it just crumbles in your hand and there's nothing left. It just, well, there's silica sand grains left, but nothing left as a chunk. So if we move back up on top here and go through the Winnipeg Sand, Winnipeg Formation as it's called, we'll go up to this cliff face that seems to be fairly vertical in through here. And this is let's say a natural outcrop. It was probably widened to some extent during the road construction for the road in behind us, but it is weathering back gradually. And this rock, for want of a better term, we've used the term Silcrete, because what we find is when we break a chunk of this rock, which is much harder than the stuff below, and well, that one's gone. Let me find a piece here that is closer in place, and I'll break it open. And the bottom line is that if I put acid on this, and I'll show you in a bit, if I put acid on it, it won't fizz. It means it's non-calcareous. That means that there's no calcium carbonate cement between these grains that are in this portion. I'd like to show you the fact that this material, this sand or this silcrete, does not contain any calcium carbonate. And the way I can do that is with 10% hydrochloric acid. And if I put a small amount of that onto this silcrete, you'll see that there is absolutely no reaction to the sand. We say that it is dead. So as the glaciers would have come over here, this would have acted like a cap rock. On Black Island, across the Strait of Water, there is a cap of limestone on top of the sand, and that's what protected that sand there from being eroded away. Here it may have been the silcrete that was responsible for the sand. Now another possibility is that there may be a very fine film of kaolin preserved on these pieces of sand and the sand grains, and that's silica, or excuse me, the silica grains cemented by the kaolin may have become very compacted, not only with the weight of a mile of rock above my head, but also during multiple glaciations as well. It is estimated that over the top of this area we might have had up to 4 kilometers of ice. So what that would have done to this kind of material under the weight of all that ice and water is really something we can speculate on, but we really don't know. So was it the weight of the rock? Was it the weight of the ice? Was it a combination of the two? All we know is that this rock is here, and it ends roughly where I'm standing, and then the material below is essentially sand, but it is also very compact as well, as you could see when I was hitting it with my hammer. So some ways it behaves like a lithified sediment or a rock, but here it's a rock up on top, there it's a sand. And this is an outcrop that is on the road to Seymourville. We're only about a kilometer to the east of the community of Seymourville. And this is sometimes referred to as the Seymourville sand pile, or it has been used for a variety of purposes. But this one is one of the few outcrops in Manitoba that has been preserved of the Ordovician Silica Sand.